In this video, I'll take you through the creation of this financial independence calculation worksheet. We'll start with the main sheet, and in here we'll have some parameters. So date of birth, the current value, so how much is your portfolio or your investments worth currently, today's date. Then we'll have a growth rate, and this is the growth rate at which your portfolio is to be grown annually. You've got your monthly withdrawal rate, and then you also have just a toggle switch here to say either 1 for annual withdrawals or 2 for monthly withdrawals. Then we also have the FI withdrawal rate. So this is if you can take money on an annual rate, how much of a percentage of your total portfolio will you take on an annual basis. So on this example, you'll take 4% of your value at a point annually. So every year you'll take 4% of your portfolio value. At what age does your retirement start? So we'll say we'll start at 60 and end at 95. And then this calculation piece here will just say how long your retirement will last. So if you retire at 60 to 95, you'll have a retirement age of 35 years. If I change this to say 55, you'll see it change to 40. In the columns, what we'll have here is months. So how many months, every month, what's the value? And if you look at the bottom, it goes to 1,200. That will give you 100 years worth of calculations that you can use. This years will simply be the months divided by 12. And this will tell you how many years you have been doing this calculation. So also after 12 months here, you can see it's 1 year. The date here is the month, the actual date of that month. So if I'd say here, this is the end of the month of today's date that we've got here up top. So I'm just going to press F4 to lock onto that. And we don't want to move any months forward, so 0 here, and this will give us the end of the month for that current month. For the rest of this month, it will work slightly different. We'll just say again, it's the end of the month, but this time we'll look at the previous month and we will move 1 month forward. So if I drag only this cell down, you'll get that date will is. The age here, if I want to calculate my age, I will just have to say, take the current date minus my date of birth. Remember to lock that cell. That will give you your age in days. And if you just say now, actually, if we take this date or this duration divided by 365, you'll get your age in years. So if you were born in 1970, on this day you'll be, or at the end of this month, you'll be 51. So if you drag that down, you can see your age continue. So if you change this, say you were born in the year 2000, you'll see then you change to 21 currently. So let's just change this back to 1970. The value will, for the first line, be the value that we get over here. This is our current value, so I'll just lock that in. Plus any growth that would have happened this month, plus any withdrawal that will happen on a monthly basis or an annual basis, plus any manual additions or withdrawals. That's for the first line. The second line will again work slightly different. Rather than going all the way to the top, you'll just say that is the previous month plus then the growth, monthly withdrawal, annual withdrawal, and the manual additional withdrawal. And now you can take this value all the way down. This has value is just a flag to say at what point does the value on this column become less than 0. So you're running out of money. That's all it really indicates. So you'll just say if this value is less than 0, then return a yes in string format. Otherwise, return a no. So now it will be no because nothing's really happening to this value. And it goes through. This month number, if we're going to withdraw money on an annual basis, we need to do it the same month every year. So we need to have a month numbering. So what that means is the first one will be 1, first month. Then you can say for the second one onwards, you're going to say if this value is 12, you need to start over at 1. Otherwise, you can just take this value and add 1 to it. So now if you take the second line and drag it down all of it, you can see it will count from 1 to 12 months and it will start over and over. So it's just a annual monthly calculation. The growth rate here, for the first month, we will assume 0. Now for the second month, we can say the growth rate can either be determined by the growth rate as we have it in the parameters, or we can have a manual growth rate over here. So let's start with the manual growth rate. So this growth is equal to previous month's value multiplied by this growth rate. Press enter. So money is not going to grow by 7,000. This is an annual rate that you get over here. So you need to divide this by 12 to get a monthly rate. And then this is everything depending on that value on top. But we must say, if we do happen to have a rate here, so it's not equal to a blank value, then we're going to take the previous month and multiply it by this rate, also again divide by 12, or otherwise use the rate on top. And there we now have nothing, so if we put in 7% gives us that, so if we want about double that, we'll say 14%, and you'll see it will jump up. So now we can drag this formula down as well. If I delete that, so you'll see if it's any month where something will be different, if I put 14% in here, you'll see that only for that 1 month it will use this calculation, otherwise it will use the 7%. So you mustn't make this 0, otherwise it will grow nothing at all. You must leave it blank. That will give us our growth rate, which will then also make our total grow over here. So the monthly withdrawal rate is going to be equal to the negative value that you see over here. So if you say withdrawal is 500 a month, so you want to take 500 a month, but you must have it negative, because when we have the values here, we just add them all up, and if it's a withdrawal, it needs to be a negative value. But now this monthly value must only be in effect if this is set to 2. So we're going to say if this value is set to 2, then we want this value to come through. Otherwise we want 0. Press enter. So we get that value of 500. If we make this 1, it comes back as a 0. So this is to make sure that we use either the monthly or the annual. So I'll put it back to 2, so you'll see the monthly value. Now we only want to take money in our retirement age. So in this example, between 60 and 95. Just to make it visual on the screen, I'm going to set this to 52. 53, so it's only 1 year of retirement, just to make this work. So I'm going to say if my age here is more than or equal to the age of retirement, then you must do all this. Otherwise, you might leave it at 0 as well. And now you'll see that value is blank, and if I drag it down, you'll see it starts there with the withdrawal. There's just a problem with the formula. Let's have a look. C6, so that needs to be a fixed value. Enter, and if I drag it down now, there you go. So now it's 500 being taken out every year. This C9 also needs to be a fixed value. There we go, that's what we're expecting. So once we reach the age of 52, our withdrawals will start. But now we also needed to end when it reached 53. So if I go back here, I'd want to say if our age is less than or equal to this age, remember the fixed cell reference, then we want to do our calculation. Otherwise we want to bring back 0 again. And now if we drag it down, you'll see it only does the retirement withdrawals between ages of 52 and 53. If I change this to 1 year more, 54, you'll see this drags down as well. So now this will match what our retirement gap is. Now let's move on to the annual withdrawal. So let's just make this first one 0 again. So the annual withdrawal must only happen when this is set to 1. The formula should be this annual withdrawal rate formula should be previous month's value multiplied by this withdrawal rate, and that will give us, in this case, 4,000. So this time we don't divide by 7, we only do this in manual or annual rate. But now we don't want this to happen on a continuous basis. If I do this down, it's going to happen every month. Also, I just remember to make this a negative value because all withdrawals must be negative to make the total value shrink. So this will then shrink every month. But we must also say, yeah, let's say if this month next to us is equal to 1, then I want to do this formula, else I want to do nothing. So if I drag this down, now the withdrawals only happen when we are at month number 1, which is what we want. We only want annual withdrawals. But the same as before, we only want to do it when we're in retirement age. So now we're going to say if our age is greater than or equal to the retirement age, then we want all this to happen. Otherwise, we want it in 0. So if I drag this down, okay, so there here we're already 52. If I make this 53, you'll see that the first one disappears, but it happens after that. So just change this back to 52, so you can see the value coming up. Now we also want to do the opposite, so we want to say if our age is less than or equal to the ending date, then we want to have all this happen. Otherwise, we want nothing to return. This C10 here just needs to be a fixed cell reference. And now you can see once we reach 54, there's no more withdrawals. And this is the manual growth rate. This years to retirement will just be the retirement start date minus our current age. So in this case, it's just 0.8 years away. But if we, for instance, were born in 2000 and we want to return when we're 52, it's still 30 years away because we're only 21. So let's just change this back to 1970. And this depletion will show us when our money runs out. So for now, I'm just going to swap this back to a monthly withdrawal. Okay, as you can see, the annual withdrawal is stuck there. So this means this formula here, we also must check if this value here is equal to 1, then we want all this to happen. Otherwise, return 0. And remember to make that just a fixed reference again. Just enter, and now if I drag this down, it will disappear. So the money, the column, only the monthly will fold in, or the annual will be folded in. So let's just go back to monthly. If we withdraw, let's say 10,000 a month, here you can see that when we reach the age of 52, we will run out of money. So this has a value. Let's just say if it's less than, let's just swap this around to more than, and drag that down. So it has a value up to here, but at this point we have no money left, and that's why we will say no. So here we will just say give me the match of no in this column. So you'll get the number 22, which means 22 rows in, you'll first find your zero. So, but we don't want 22 to come through. We actually want the year count to come through. So this what's in this column. And now you'll see in 2 years, this just shows 2 because it is formatted. So if I click on home and just make it, give it more decimal places, you'll see it's 1.75, which is what this is equal to here. So the next, rather than saying the years, is how many months, so the formula will be the same. I'm just going to paste it in here and in here as well. So it's all the same formula, but rather than saying how many years, I want to see how many months. So this B, which is years, must be changed to months, which is A. So I'm just going to change this B here to A. And now you'll see in 21 months, so if I just make it slightly more accurate, so in 21 months you can see, well, the months will always be a fixed number, so we can leave that without any decimal places. And the age is in column D. And this one we can maybe put some decimal places. So if I do my model according to this calculations, from today, 1.75 years from now, or 21 months from now, when I'm 52 years old, I'll run out of money. So this is just to make sure you don't withdraw too much money. So if I change this to something small again, let's say 500, you'll get an error, meaning it doesn't run out. So just to fix the formula, we'll just say, if it's an error, then show a blank cell, and we'll do this for all 3. So that now, if it does run out, I can take 5,000 a month. It will run out in 2 years, so let's make it something in between, say maybe 2,500 a month. It doesn't run out. If I make it, it doesn't run out, it means it doesn't run out in my retirement. So this is a very short retirement. If I change this, I want to retire when I'm 55 and I must live till I'm 95. Then you'll see I will run out in 9 years from now, 109 months, which is when I'm 60 years old. So if I take 2,500 of these calculations, I don't have any more money, and it only grows by 7%, I can take 2,500 for the ages between 55 and 60, and then I will run out of money. So this is when you'll have to make this much less. So if I make this 2,000, you can see I make it to 61, so make it 1,500. If I make it 1,000, so this will give you different ages at which you will run out of money. You want this value to be a blank, which means you will not run out of money. So now let's add 2 graphs. So what we're going to do is take our table of values and just insert a table from here, click OK, And what I'll do is on top here, I'll just make it not formatted. So this is now just in a table format to make the graphs or the pivot tables work more conveniently. So if I take this pivot table and I click on insert a pivot table this time, click OK. Now I can say make the age my rows and the value the values. I can just change this formatting here just to a financial formatting, and this will be the value per age. If I now insert also under the pivot table a pivot chart and I make it a line chart, I click OK, just make it bigger so you can see clearly. I can remove all these buttons and take this legend and headings out. This looks very impressive, but it's unlikely that you'll live until 150. So what you should do is in this row labels, just change the label filters to be less than or equal to the retirement age, which we said is 95. And this will give you a more realistic. So between the ages of 51 and 95, this is what will happen setting these parameters on top here. I'm just renaming this sheet to a value chart. Here you can now see what's the difference between taking money on a monthly basis, and now I can change it to annual. Because these are pivot table related, I have to click on the data here and click on the refresh all, and you'll see a different characteristic of the graph, where every year I take my 4% and let it grow, take 4% and let it grow, and that's why you get this jagged effect. And as long as you take less than the market growth, you'll be able to take more and more and your money will still grow. But you want to see how much these withdrawals amount to, so what we'll do is just take this table again and insert a new pivot table. Can use the age as the values again, and you can see this annual withdrawal. You can take it as a page filter on top. So these are the months of our lifetime. We're going to take an annual amount. So I'm just going to select all except the blank value. So you only can get money in these values, but because those values are negative, I want a graph of positive values. I'm just going to click here and create a calculated item to say, let's call it annual. And the formula is just, it's equal to minus the annual withdrawal. And I'll click OK. And this is how much we can get annually. And then also I want another calculated field just to say the monthly value is equal to this annual that we just created divided by 12. So that's the graph. I will just rename this to annual. You can't just rename it like this. I'll put a space there, and same for monthly, and put a space there. So this is what we need for our second graph. If I now click on this and add a pivot chart, this is what we need, a column. Click OK, and this is our graph. This is not exactly readable because the annual amount is so much more than the monthly amount. So what we'll do here is for now just hide all these buttons and take the legend out again. And now with this selected, if you click on the design and change chart type, you click on combo at the bottom here, you can make, say, the monthly a line graph and the annual a column graph, and I'll put this on the secondary axis, click OK. And now the line here represents this value. If you hover over the line, you'll see it's 451, which is that amount over there. And that over with the bar is the 5,200. So this is how much you can take per year, and this is how much it's can be giving you per month. So the monthly value is on the left, the annual value is on the right. Now, if I go back to the main chart, I'm just going to rename this to the FI chart. If I go back here and say, for instance, I now say I've been born in the year 2000, I already have 200,000. My portfolio is going to grow by 8%. I'm going to leave it at annual, and we withdraw the 73%, and I want to retire when I let's say 50. So I'm going to have a retirement of 45 years. If I click on these charts, they will look exactly like before because they're based on pivot tables. To update them, you have to click on data and refresh all. This graph will always go blank. What you need to do is just select there again, select all and untick the 0, and you'll see your value there. When it's been blank and you see something like this happen, just click on this row values here and make sure it stays sorted so that your age is in chronological order, and then you'll see what you expect to see. So because this person, I've changed it to him being only him or her being 21, this is a much longer period, and now that's why it grows so much. So this is the way the calculation will work for this chart. Here again, just make sure if you see something funny like this happening, that this just remains sorted chronologically, and then you can see the withdrawals happening over there. Now with this calculation, you can work out all different variations of the financial independence calculation. On the link below, you'll see a video where I actually explain this in detail, and there's also a download link for this file. It's slightly formatted differently, but it's the same calculations. What you can do to make sure that this updates from time to time, if you click on this and click on tables and click on this options, you can just say here the data must refresh when you open the file. That will just make sure that even if you forget to update this graph, it will update itself the first time you open it. So I'm just going to click on both of these graphs, and you'll see, because I changed it for one, it would have changed it for the other one as well. So all this means is when I do open this file now and I forgot to update this data, so when I click on data refresh all after every change of parameters, if I forget this will automatically happen next time I open the file. And this is how the calculations work for this worksheet.
Hi, this is Anton from the Data Developer channel. If you've liked this video, please consider giving it a thumbs up below and subscribing to the channel. And thank you for watching.